Ever wondered what biological antimatter is? Imagine life made of antimatter, a mirror to our own existence. Antimatter is rare, found in high-energy experiments, not daily life. We've seen antimatter hydrogen, but few other elements. Why is biological antimatter significant? Our theories predict matter-antimatter symmetry, yet life is all matter. Why do we live in a world where life is only made of matter? It's a mystery that challenges our understanding of the universe. What is antimatter? It's the mirror image of the matter we know. Electrons, protons, neutrons, these are particles of matter. Positrons, antiprotons, antineutrons, these are particles of antimatter. In high-energy experiments, particle-antiparticle pairs often form. Antimatter's existence ties to quantum states with negative kinetic energy. Classical and non-relativistic quantum particles only have positive energy. Relativistic quantum mechanics combines quantum mechanics with Einstein's relativity. It predicts quantum states with negative kinetic energy, explaining antimatter. Grave-de Peralta's equations show states with both positive and negative energy. So why life as we know is made of matter, not antimatter? That's the mystery. The Planck mass marks the first classical quantum frontier for both matter and antimatter. But there's a twist. The Planck charge is a second frontier, only for antimatter. This breaks the symmetry, leaving matter without a second frontier. If an antiparticle's charge is less than the Planck charge, it's quantum. But if it's over 11 times the positron's charge, it's classical. Only quantum antiparticles can form stable antiatoms. So, antiatoms with more than 11 positrons, they just can't exist. This explains why there's no periodic table for antimatter. Without antimatter chemistry, biological antimatter is impossible. And that's why life, as we know it, is made of matter. Imagine a world where the Planck's mass marks the boundary between classical and quantum realms for matter and antimatter. This boundary is defined by the size of the common wave, where particles and antiparticles have positive kinetic energy. The Planck charge is another frontier, only for antimatter, defined by the size of the exotic wave, where antiparticles have negative kinetic energy. Picture a charged antiparticle in a box, a simple model for confined quantum states. The box size dictates the size of the exotic wave, where the antiparticle has negative kinetic energy. To find kinetic energy, we solve Grave-de Peralta's equation for these exotic states. We simulate interactions with repulsive Coulombic potential energy. The antiparticle's total energy is the sum of kinetic and potential energy. The stable size is where this total energy is maximized. We discovered that the exotic wave collapses if the absolute value of the charge exceeds the Planck charge. Thus, only antiatoms with less than 11 positrons can exist. This absence of a periodic table of antimatter explains why biological antimatter is impossible. And that's why life, as we know it, is made only of matter.
Grok XAI concluded, there is not any evidence contradicting the impossibility of the existence of life made of antimatter.
These books are available on Amazon. Search Amazon by the author's name, Luis Grave de Peralta, Luis Grave de Peralta, Luis Grave de Peralta, based on using a pair of relativistic but Schrödinger-like Grave de Peralta's equations. Happy reading!
Prof. Grave de Peralta invites you to visit his websites at YouTube, X, TikTok, and Facebook. And please always think by yourself.